Hey, what's up, Hacksters? We have here David and Robert. What are you doing here at Arm TechCon?
Having fun.
You have some crazy machine.
Basically, what we wanted to do for this machine was create a self-sustainable, self-contained way to develop on ARM devices. And teaming up with mini nodes, 96Boards, Linaro, and then just kind of like bringing in a little bit of passion about STEM education and solar renewable energies.
Yep.
We decided to build this nice little kit here. This is kind of all DIY, right? So I went to Home Depot, picked up a lot of these parts, got some stuff on Amazon. But essentially, what it is a mobile access node powered by multiple variable power inputs, right? So right now we have solar going, and then we have a power supply in the back that's giving it the power that it needs to charge the battery and run the different devices that are going on. Now, one of the most important parts about this is that we wanted it to be self-contained, and we wanted it to essentially run on its own without any input from the grid. So here we're collecting energy from a power supply, but essentially if you picture this out in the wild with sun, then you would have all solar power.
Yep.
Another interesting part about this is that we're running this on a 96Boards, which in this case is the Dragon Board 410C, and we have an LTE Mezzanine right here, which is pulling in LTE signals, 4G signals. So we're not connected to the Wi-Fi here at the convention floor. We are completely remote. Yeah, so remote power. Totally independent. And so one of the biggest things about this particular device is that we wanted to showcase the use case, or the foundational use case, rather than any of the use cases that people on the floor might picture, right? So we have the foundational application providing people with kind of the ideas that they could use this box for. In this kit, we have kind of all the essential components that you need to run a solar system or a solar generator. Power is created at the solar panel. The solar panel then drives or pushes its power up into the charge controller. The charge controller is what a lot of people call the brain of the solar generator. So we have the solar panel coming in on here, but then also I wanted to have two variable power inputs. So essentially have some buttons down here that you can't really see, but these buttons, some switches. You can take in two power sources. One is a solar panel, and then one is anything else that you want. So I could turn off the solar panels and then just run on one source, or I could turn off the solar panel and the source and run on the batteries. Yeah. So solar panels go to charge controller. Then we have batteries.
Yep.
Those go up to the charge controller. And then we have an inverter, which basically takes DC, turns it into AC. That goes up to the charge controller. So essentially, power input, power storage, and load. And those are the three big components here. Yeah.
So then, obviously, power output comes over to the Dragon Board 410C. The Dragon Board has connected to it that LTE Mezzanine. So that LTE Mezzanine, at the moment, we happen to have a T-Mobile SIM card in there. It could work with AT&T, it could work with Verizon. I think we might get a little bit better coverage based on the commercials that I've seen. Some of the commercials about with the map and whatnot. But the point is that LTE Mezzanine comes in and provides connectivity to the Dragon Board. The Dragon Board then shares that connectivity out over an Ethernet connection to a Raspberry Pi compute module. Okay, the Raspberry Pi compute module is then connected to essentially the internet at that point over that cellular connection. The Raspberry Pi compute module is running Microsoft Azure IoT Edge. That is one of their products that allows you to remotely interface with edge devices. I can see telemetry coming off of the Raspberry Pi, and I can actually remotely deploy and push containers to that Raspberry Pi as well. So I can push code, push containers to that Pi essentially anywhere that there is sunlight and a cellular connection. And I know that we're on 4G LTE in here, but it will fall back to 2G if you get really far out into the wild. So you could be out really truly in the middle of nowhere, and as long as you've got cellular coverage, you can grab telemetry in and push code to the device. So that box can be sitting pretty much anywhere as a proof of concept, just from an innovation and demo standpoint. We've got some pretty basic panels at the moment, but
how much do those provide? I mean, it depends on the sun.
Yeah, so these are 10-watt panels. So 1.2 amps total. I have them running in parallel. So we have 10 watts, about 0.6 amps, 0.6 amps. So essentially, this is strictly for the purpose of demonstration. We would actually have larger panels if we were running this out somewhere else. And we're not taking up the full space of the back. So if I kind of bend this in a little bit, the camera's probably not going to see it, but you can see the panels just clip right into the back right here.
Panels slide right in.
Yeah.
So it's a
Yeah,
whole,
so you can. It's all self-sustainable. You can take it with you everywhere.
Yep.
Yeah.
Carry
really
it by
nice
the
3D
handle,
printing.
and away you go.
Yeah.
Did you do all the 3D printing?
So actually, I'll mention this person right here.
Bring it in.
Gabriel D. Peterson did all the 3D printing for us. He did all the design. So definitely go check out Gabriel D. Peterson on Instagram. He's got a lot of cool stuff.
Nice.
Yeah.
We're calling this Rev 1 too, by the way. So we do plan on pushing all of these STL files, all of the schematics that were drawn out for the design of the box itself. We plan on, and the bill of materials, we plan on pushing that all up to a repository under the 96Boards-projects org on GitHub.
It's definitely a proof of concept right now, but we can get all of that published out. One of the other things we should probably talk about is that Shiratech Mezzanine has additional capability because it has on it the motion detector. It has on it the motion sensors. It's got on it, I believe, a camera or infrared input as well. So this self-contained box, if you start to then leverage some of those capabilities, you could drop this box out into a remote location, and if it's got the motion sensor on it, it could detect earthquakes and immediately report back. If the camera recognizes a change in the scenery and the imagery, wildlife coming by, poacher coming by, a vehicle.
Someone grabbing the suitcase and
it could have someone picks up the suitcase. A vehicle approaching. It can then feed back into the Azure Command and Control Center to remote monitor, remote environmental capability as well. Since it's self-contained, I think take advantage of some of those sensors as well. I
think at the core is kind of like this is foundational kit that is basically can be used for any type of application, right? So like David just mentioned, you can use this kit to basically go throw it out into the wild, collect sensor data, or if someone tampers with the kit, it'll notify whoever owns the kit. Lots of different applications there. We're using it today as this somewhat of a server situation, right? So we're hosting a node, and you can use it as a server.
We're only running one node at the moment. But,
so what kind of a node is that you're running?
So that is a Raspberry Pi compute module. The compute module is essentially the core guts of the Raspberry Pi 3, but without any of the ports. Everything is just exposed over the pinouts. We've also got in a later iteration coming. It's not complete yet, but
we'd love to hear about future plans.
Yeah, future plans. So this is a carrier board that holds 5 Raspberry Pi 3 compute modules.
Oh, I want it.
Each compute module. Each compute module.
You made a mistake handing this to me.
Each compute module. I got a spare. Each compute module is quad core, 1 gig of RAM, and 4 gigs of eMMC. So you can essentially then scale up on this prototype up to what you would be looking at is 20 cores of compute, 5 gigs of RAM, and 20 gigs of storage. So, it's certainly not a supercomputer, but it is absolutely plenty of power to send out into an edge location. And all it needs is one Ethernet connection, which we will get from the Dragon board, and one power supply, which we'll get ultimately from the sun.
So good.
I like this because you can offload a bunch of the processing and storage onto something like this, and then you can use something like the 96Boards to maybe do some of the more hardcore processing. So if there is something that you need done at the edge, you can actually do a lot of stuff here, but then also offload other things onto any sort of processor board that's being
so you can use them
strictly
strictly as the compute. TensorFlow runs on there.
Yeah, so you got a little...
Yeah, well, I had to label it.
The Azure one labeled here.
That one's the Azure node. Yeah, hey, they all look the same. I had to label them in order to figure out which one is running which workload. But I was able to push that TensorFlow container straight from Azure. The image recognition can be done on the module and then pushed back up to Azure from there. And I happen to be using Azure. Google Compute certainly would work as well. They have products and services available for pushing containers. I believe Amazon does as well. I didn't explore it, but I know that they have some IoT initiatives also.
Whose Aperture Science logo is this?
That is Gumstick's logo.
Oh.
Gumsticks was the one who helped design this carrier board.
With Geppetto, so through Geppetto.
Yeah, through Geppetto.
So
right.
Geppetto is an online kind of design tool that you can use. In fact, the guy who just came by and shook my hand is Gordon. He's the CEO of Gumsticks.
Yeah, he helped us lay this out. I am not a hardware designer by trade, so I needed some help, but they were fantastic and helped all along the way, all through the process. And they helped design the board and prototype it.
Super cool. You even got the 96 or the Ultra 96 here.
Yeah, Ultra 96.
Yep.
Basically, 96Boards is a partner-based department or section of Lenaro, which is our parent company, also a booth here at Arm TechCon. But 96Boards is essentially a standardization, so a specification and a standardization that follows a very standard footprint and peripheral or port output, right? So essentially all of your I/O is lined up, your USBs, your display, your SD card, and multiple other facets of this particular design are lined up, and so you can basically consume an entire ecosystem with the same footprint across multiple SoCs. So our specification is SoC agnostic, meaning you can find, for instance, like this, I'm holding up a ROC 960 and an Ultra 96. ROC 960 has the RK3399 chipset, while the Ultra 96 has the Zynq UltraScale Plus chipset. The Aero Qualcomm Dragon Board 410C has the Snapdragon 410E chipset. You have Huawei chipsets. There's a bunch more with Action Semi chipsets, et cetera, et cetera. Yep. And so by taking on this footprint, you've essentially enabled yourself the entire ecosystem. And so you can take Mezzanine boards, similar to like the Raspberry Pi Hat or the Arduino Shield, and you can just plug and play across your different boards, consuming different functionality within the ecosystem.
Yep.
One of the more interesting ones that came out recently, this is a FPGA-based Mezzanine, so it plugs in just like it would any of the boards, just like that one did. But you have a Arduino Shield breakout, and you have a Raspberry Pi breakout.
That's so weird.
So
cool.
Yeah, the FPGA translates the signals. So you can plug any Raspberry Pi Shield into this board, and then take advantage of the Raspberry Pi ecosystem along with the 96Boards ecosystem.
That's pretty cool.
Do you want to speak a little bit about mini nodes and what that is before we?
Yeah, absolutely. So for mini nodes, what we focus on is tiny servers. So I run mini nodes as a web hosting company, a server hosting company, I should say, and we strictly focus on small single board computer hosting, and we also strictly focus on ARM.
So I don't rent a Raspberry Pi in the cloud.
You absolutely can do that. Yeah, you can rent a Raspberry Pi in the cloud. That's exactly what it is. Certainly, a Raspberry Pi is not the most powerful computer in the world, but it definitely suffices for many, many different types of workloads that customers have had. Customers use them for testing their code on ARM. So I see customers come through that want to test a new application, make sure that it compiles and works on ARM. Some people have pretty modest needs, IoT type of services, communication services that really just need modest capability. And
do you hook up storage? Do you hook storage up to those?
No, we stick with the SD card just to keep everything local per board. And so that's the whole premise, is that not everybody out there needs a gigantic Xeon server with 128 gigs of RAM and 20 or 30 or 40 some odd cores and threads. There are individuals out there that have more modest needs. And the Pi works just fine for that. I also host 96Boards devices. So we have quite a few LeMaker Pi keys in the environment also. And that is 8 cores, 2 gigs of RAM, and 8 gigs of eMMC. So a little bit stronger than the Pi, and native 64-bit ARM architecture. So again, there are some people that want to test 64-bit ARM compatibility. Some people just want to ensure Raspberry Pi compatibility. So the point is we offer both, and then customers can choose.
Thank you so much.
Thank you.
All right. Thanks.